All right, so to begin with today, we're talking about getting exponential equations out of sequences. But before we show you how that works, let's do some review. On this one, how would you start? Don't even do it, just tell me how would you start. Add 1. After you added 1, then you'd put it to the power of what? 3/2. And then what would you try not to forget at the end? Plus and minus. In this case, it has a plus and minus because we did a square root on both sides. By putting this to the power of 3/2, you're taking a square root. If that's an even number, you got to remember a plus and minus. Final answer, x equals plus and minus. What is the square root and then cubing 1? It's all 1. There we go, plus and minus 1. All right, try this one. Common bases. Got to get the bases to be the same. The answer for this one came out to -2/3. All right, on to the next one. This one, you got to simplify this a little bit, and then when it's all done, your answer will have a y in it. Just try to write it as simplified as possible. That's the challenge here. Many of you can get it to where you'd get half credit, but not many will get it totally right, where they simplify it all the way. Okay, so try solving that one. I think we've done enough of these. I don't need to tell you what to do other than start by simplifying it, clear the fraction, see if you can do it yourself. All right, I'll do the first part here just to give you the idea. That goes up, this one goes down. This change to 3 goes in here once, 3 goes in here 4 times. So it ends up being x squared over 4y. That's how you start. Right? X step multiplied by 4y, x squared equals 8y. Then square root, square root, square root, x equals square root of 8y. First of all, how many of you remembered the plus minus? All right, there was a plus minus because we just square rooted both sides. And then how many of you, actually I want to know, I want you to check the other person. See if anybody actually did something simpler than that. Turn and show your neighbor and see if they did something simpler and better than that. By the way, I don't think this is much better. This is just the same thing. I mean something better than that. Okay, verdict. Did you see anything better than that? Raise your hand if your person had something better than one of those answers on the board. Only 4 people, all right. Maybe 5. All right, let's see. So, I think what's better here is if we take this part and we take this part and we zoom in on the square root of 8, you can't really simplify the square root of y very much, okay, but you can simplify the square root of 8. The square root of 8 can be broken down. Do you remember this? And the square root of 4 and the square root of 2, and that makes 2 root 2. That's what I was looking for. So x equals plus and minus, because we did square roots on both sides, 2 root 2, but then where does the y go? Inside, because the y was underneath the square root here, and it still is. There's the best final answer. Did anybody have that on your paper? Nice work. That's impressive. Okay. Moving on. This one. Square both sides. See what you get. Okay, now we're going to give this one a try. It's squaring both sides gives us x minus 4 and 5x plus 1, because squaring just undoes those square roots. It is as simple as that. Now I'm going to subtract from both sides an x, and I'll get -4 is equal to 4x plus 1. Now I'm going to add 4 to both. No, wait. I'm going to subtract 1 from both sides. -5 equals 4x, and therefore divide by 4, 5/4. -5/4. Now, did you check it? That was smart because this is one you get a profile and see if there's any chance that this would cause a problem. If I stick the negative 5/4 back in right there, use red so I can write over it, negative 5/4. I get negative and then a -4. That means negative. It's still negative. Square root of a negative. It's illegal. Can't do it. That one is wrong. I know you'd end up with a similar thing on the other side, but they're both wrong. You can't have negatives under square roots. It's imaginary. The only way you could answer it is say there are imaginary solutions. That's the only solution you could give. All right, moving on. This one. Add 5 to both sides, then go. Let's do a race on this one. As soon as you got it done, turn it my way. Oh, that's totally cheating. Did you do it early or not? You know, okay, how about you?
No.
Okay, what did you do? Ha! Nice. Okay, the race thing has failed. All right, so you should have added 5 to both sides. Then you should have gone to the power of 3/4. All right. And then I bet a lot of people forgot this because the answers I did see didn't have it. Absolute value of x plus 2 equals square root of 16, the fourth root of 16 is 2, 2 to the third is 8. I bet a lot of people would have thought the answer is just 8 and negative 8, but it's not. Okay, so do you get what just happened here? When I did a root on both sides, that brought in the absolute value of, and I guess some people have at least figured out that there's a plus and a minus involved, but you still haven't understood the whole absolute value thing. When you square root a variable, see there it is, and you just did a square root of it, you got to bring in absolute values then. Then that breaks it up into two equations, x plus 2 equals 8, and x plus 2 equals negative 8. Notice this is identical to this except for one negative sign right there. So there is kind of a plus and minus involved, but it's not as simple as plus and minus 8. Now I subtract 2, x equals 8 minus 2 is 6, and I subtract 2, x equals negative 10. And after all that, should I go back up and check them? Well, this one doesn't have the square root, so I don't have to worry about it as much. It's usually the square root ones. Now, is it possible that the little old lady could be a terrorist walking into the Metrodome? Yes, she could, absolutely. So is it possible that this, even though she's not wearing the baggy coat, you know, Grandma might have it hidden her cane or something. Maybe it's a machine gun, not really a cane. Anyway, that 6 and that negative 10 might fail. But I checked it last hour. I can tell you they don't fail. They work. So, all right. Any other questions about this one? Okay. Moving on to this. Set it up. So much cheating going on right now. Here's how I would have set it up. A to the negative 4, well, equals a to the 10. And then I got to do something else in here. What'd you do? Negative 4 plus x or minus x or just x or what? Minus x. Because when you have them like this, you subtract. That is correct. So then negative 4 minus x equals 10. And it's just a matter of being careful with your negatives now. So you add 4 to both sides. Negative x equals 16. Then I did the negative on the other side, negative 16. And then should I double check it? Well, it never hurts, but uh-oh. 14. Now, I was just about to check it, and I would have caught that. I want to put that on the record. Because I was just going to say negative 16 and put it in here and see if it worked. And I might have noticed that, wait a minute, that's not going to all cancel out right. And it wouldn't have. So there, now I can check the negative 14. It's another good reason to check yourself, though, right? Because if you did make a dumb mistake in there like I just did, just a simple adding thing, it would catch it if you do check it. So now I can see if those guys go up to the top to make them happy, and these guys go to the bottom, make them happy, then I'll have a 14 over a 4, and it'll cancel 4 of them, and it'll be a to the 10th, and that's what I want. So it works with negative 14. Moving on. This one, in your head. Don't even write anything. Just write the answer. Think about it. 3 steps. That negative is just a flip. How many are thinking of this in your head? Raise your hand if you knew that. Okay, good. If you didn't know that, what you should have done is a square root of 25, which is 5. Then I would have done the cubing. 5 cubed is 125. Then I would have done the flipping. 1 over 125. All right, on to this one. This is a problem that is a blast from the past. About a week or two ago, we finished up a unit on this. Remember these? Okay, it's going up by 25%. And if I wanted to change that into an exponential, the key things, would you agree, this number is key and this is very key. You have to have those, right? All you'd have to do to write this as an exponential is, I've got it over on this side of the line now, that. Now let's just do an example of one so that you can understand how these work. If you grab your graphing calculator or a regular calculator, even is fine. Take 500 and times it by 1.25. That'll tell us that our first term is 500 and our second term is, I'm going to borrow and leave an item, a pack of gum. Not good enough, not good enough. Leave the hat there. You're not supposed to have a hat on anyway. Oh, and you need to take your hat off too. And you need to take your hat off too. Thank you. All right. So 500 is your first term. I just want you to use the calculator and multiply 500 times 0.25, and you'll be able to figure out your second term. I want to know what the first 4 terms are. Mr. G, do you have a calculator? Okay, so just sit there. Give me some collateral. All right, Mr. IM, instant message. What did you get? Yep. Well, the first one's 500, but the next one. What? 625. Yes, I can believe that. I didn't hear that. Okay. And then the next one after that, have you done that yet? Point what? Row. Okay, what about the one in the middle? 7 what? And then the last one was what? All right. Now, I just want you to verify that if you type in, for instance, x to the 3 right here, that you're going to get the third term. See if that's true. 500 times 1.25 to the power of 3. Enter. Are you going to get the third term or are you going to get the fourth term? So what did it come out to be? Is it the 976 or is it the 871? 976. Do you get how that's the fourth term? Do you get how that could be confusing? Yes, sir. Exactly. U sub 0 is 500, but still, that is the first term, isn't it? So that's the first term, no matter how you slice it. That makes that the second term. So this is the third and the fourth term. So it's giving us the fourth term. So you get how this has that little flaw in it? Got to be careful on those. So if they tell you in the first year, what do you start with? Well, what you start with is actually here. After 1 year, you put in a 1. That would be after 1 year, you'd have the 625. Anyway, it works just fine. It's just you got to be careful. If you just put in a 3 and think you're going to get the third term, you're sorely mistaken. Move on to the next one. I want you to look at that equation. It's just a little different. And then write me what the exponential equation would be. You got to take the important parts out of the one to make the other. I hope you said 75 times 1 minus 0.15. If you actually change that to 0.85, it's not wrong. 1 minus 0.15 is 0.85. But it's smarter to leave it this way because it tells me my rate of change right there. It's 15% decay in this case. Okay? So now I ask you, this can be confusing, so think it through. If it's 75, if I'm starting with 75 goats, and my herd is going to be depleted by 15% per year, how many goats would I have after the second year? All right, so you all get that I'm starting with 75 goats, right? That's at the beginning of year 1. How about the end of year 1? Do I still have 75 goats? No, and of course it depends on what this is about. Is it like on the last day of the year they cull out, they take 15% of the herd? It's called culling, and basically you cut down your herd. You usually want to take out the ones that aren't as healthy so they aren't breeding and making babies that are less valuable and whatever. So you cull the herd down. Maybe it's happening all on the last day. I don't know, but I can tell you this, at the end of the year, you have less. So that would be if you put in a 1 right here. And you'd have 15% less. And so you'd go, I'm going to get to the answer in a second here, but I think some of you are going to have the wrong answer, and I want you to see why. So I go 75 times the 1 minus the 0.15, which is 0.85, and that would be 63.75. That's kind of by the end of the first year. You get what I'm saying? So the end of the second year, let's put in a 2 and see what happens. We'd have 75 at the beginning times 1 minus 0.15 to the power of 2. 51.187. And where should I put that? Well, this is kind of like the beginning number again. Began that year with 63.75 and it ended that year with 51 point, I'm going to round it to 51, no, 54.2. So at the beginning, the very beginning was right here. At the end of the first year was right here, but that's still kind of in the first year. And then this started the next year with that, and then that's the end of the second year. Okay, so at the end of the second year, you could just put in a 2 for your equation, and you'd get 54.2. Okay, get how that's different than the second. It's not the second term. This was the first term. This was the second term, which was identical to that one. And this was the third term. So it's actually the third term that I'm getting, but it's at the end of the second year. All right, so if you're doing a real world problem, you can trust these numbers like 2. 2 years, put in a 2. But if you had been doing I want to know what the fifth term is, you can't just slap in a 5. You get how that's always been different? Like the fifth term is not always at the end of the 5th year. That's why I always said on the real world problems, you should pick u sub 0. All right, because that worked well for real world problems. All right, see if you can set this one up. Cockroach question. Takes a census. He figures out he's got a population of 18 cockroaches in his house. This happens actually a lot down south. We don't get cockroaches up here in the north. I think it's the super cold winters that kill them off outside. But anyway, the cockroaches are a big problem in some parts of the world. In fact, down in the Caribbean, they tend to have a problem with them down there because there's never any cold weather to kill them off. Cockroaches are tough too. In fact, they can handle radiation. So some people say that in the end, the cockroaches will inherit the earth because if there's a major nuclear disaster and like countries all launch their nukes at each other for some reason, that the nuclear radiation would kill off all the human beings, the cockroaches would still be fine. They're seriously really, really, really tough to kill. So you should have an equation here, y equals 18 b to the x. But I know what b is. It's 1 plus 0.15. Do you get that? The starting value is right here, and that's how much I know it's going to grow by. Determine how many there'll be in 3 weeks. It's a real world problem. You can just trust the 3 and drop it in there. If it had been, what's the third term? You wouldn't be able to trust it. But we can trust it for real world ones. That's kind of handy because we're going to do mostly real world problems. So if you can just pop that into your calculator, this puppy will be easy. Raise your hand when you've already got it. Okay, I got 5 people. I'm going to wait. Type that puppy in and I'm going to call on somebody. Do you have a calculator? Hey, you see a problem with that? Okay, make it better by getting one of mine. I shouldn't have to catch you halfway through the class. It's not good. All right. Mrs. SM, can you tell me what the final number is for our Y after those 3 weeks? Now, do you see a problem that we're being a little too mathy and a little too not enough real world? What should it probably a better answer be? 27. Probably 27, yeah, because that rounds to 27. And say the guy should expect there'll be like 27 cockroaches by then. Any questions? Okay, next one. Sally Mae's going to start brushing her teeth. The dentist told her she only needs to brush the teeth she wants to keep. So she starts brushing for 5 minutes. She continues to increase her brushing time by 5% per day. How many days will her brushing sessions, after how many days will her brushing sessions be 12 minutes long? This one's particularly confusing because you know how time is always X? But time is, in this problem, the number of days she's been brushing, but it's also an amount of time that she brushes each day. You get what I'm saying? It's like time inside of a time problem. It's like the inception of time problems. All right, so what do? Well, first of all, you can make a y equals ab to the x thing for it. What's a always? Starting. I always start with 5, so I can do that. That's easy enough. And I always then try to figure out b. Well, I've got the 5%. That's easy enough. 1 plus 0.05. Do you agree? Okay. So now, where do I put that 12 minutes? There's 2 choices, X or Y. Her brushing sessions will be 12 minutes long. It is Y. Okay, now the problem with that is that you would not know how to solve that. I want to challenge you. Do anybody have an idea on how you could solve that? Guess and check could actually work. Take a long time. There's a math way to solve it. All right, I gave you this at the beginning of the year and said this strategy would be good for solving pretty much any ACT, many ACT questions, and it would be super handy. Really close. Yes, it's on there. What did you just mention? Using the what? The XY table, but that's not what I said to do. I'll say it again and see if you recognize this. Graph both sides and see where they cross. That is a really good ACT strategy. If you have a graph and you have 2 things you can graph, what you're always looking for is where they cross. So if you were to graph this one, it would actually look kind of like what I just drew there real quick, kind of more like that. And wherever they cross, that's the answer. So you graph both sides of the equation, see where they cross. Now, I don't need you to do that right now, because that's actually a little more complicated than we would end up doing in class. But I just wanted to share that with you because I thought maybe I hadn't talked about that in a long time, which apparently I haven't. So if you graph both sides of the equation, y equals 12 and y equals all that, and you see where they cross, that's the answer. But I'm going to instead give you a problem that's more like what we would do in class. We wouldn't ask you to do that one. We would say after 12 days, how many minutes are her sessions? that obviously means I don't put it in this spot like I did last time. I put the 12 in this spot. After 12 days, you put the 12 there. Now it's going to be simple typing in the calculator. From there, you could get a small child to get the answer. What do you get, by the way? Isn't it like 8 or 9 or something like that? Let me type it in. Anybody verify that? 8.97, so that's about 9. About 9 minutes. 8.97. If they tell you what to round to, you use that. All right. That's all we got. So let's go to the homework for today. And I'm going to give you a few that you can skip and a few you should do. All right. So that's all I have for the lesson for today.